Welcome to lecture number 22. My name is Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay, Mumbai, India. The name of the course, Geosynthetics Engineering in Theory and Practice. This is Module 5, Lecture 22, Geosynthetics in Pavement. Recap of previous lecture: design of reinforced road, design parameters, design chart, design procedure, joining of geotextile, raft repair, calculation of critical dead weight of vibro roller. So these are which we have covered in our earlier lecture. Now we will explain the stress reduction downward with depth of granular frill, that is Renkolar and Bonner 1997. The reduction in presence of the downward up to 1 meter depth of the granular field can be calculated using this equation, that is PR is equal to 0.9 Tp into 10 to the power minus 6 D, where PR is induced pressure at any particular depth D from the surface, that is kilonewton per meter square, and Tp surface pressure of tire, this is kilonewton per meter, and D is the field depth, that is in meter. So if the subgrade soil is within 1 meter depth, the applied pressure on the subgrade due to the surface tire pressure PR. Generally, cohesive strength of the subgrade soil should be 1/5 of the load on subgrade to support the vehicle. Here I am giving one example. Let us weight of the heavy vehicle is 1800 kilonewton. This weight will be equally shared by 4 tires. So therefore, load on each tire will be equal to 1800 divided by 4 is equal to 450 kilonewton. And contact area of the tire is 0.6 square, that is equal to 0.36 meter square. Surface pressure of tire Tp is equal to 450 divided by 0.36 is 1250 kilonewton per meter square. Let the subgrade is at 0.9 meter depth from the surface. Calculate the induced pressure on subgrade soil. Also calculate the required cohesion of the subgrade soil to support the vehicle. Now here is the solution. We know the equation PR is equal to 0.9 Tp into 10 to the power minus 6 D is equal to 0.9 Tp is given 1250 into 10 to the power minus 6 into D is 0.9. So if we calculate, then you will have PR is equal to 1125 into 10 to the power minus 0.54 is equal to 1125 into 0.9 is equal to 324 kilonewton per meter square. So induced load on the subgrade is 324 kilonewton per meter square. Generally, cohesive strength of subgrade soil should be 1/5 of the load on the subgrade should support the vehicle. Therefore, minimum undense shear strength of the subgrade soil is equal to 324 divided by 5 is 65 kilonewton per meter square. So we will now discuss advantage of the unpaved road. Maintain the separation between the subgrade and the subbase. Reduce the required amount of good quality aggregate. Minimize the rust depth. Construction of road is very easy. Site preparation is less. Reduce the depth of excavation. Prevent contamination or migration of the subbase material, prevent failure of pavement structure, improve drainage system, provide stabilization, reduce intensity of stress on the subgrade and reduce differential settlement, extend the life of pavement and reduce maintenance requirement. Now, I will address the design chart of US Forest Service USFS for unpaved roads. Stuart et al. 1978 developed a design method for US Forest Service. This method has the following limitation. The aggregate layer is cohesionless, non-plastic and compacted to CBR is equal to 80. Undent shear strength of the subgrade is about 90 kilopascal or CBR less than 3. Physical passes less than 10,000. Geosynthetic serviceability criteria should be considered. This method includes the following parameter: physical passes, what will be the tar pressure, what will be the subgrade strength, what will be the axial configuration and rod depth. So, this table gives that condition, rod and the traffic and what will be the bearing capacity factor. We will calculate the bearing capacity factor using this table depending upon the rod, traffic and number of the process. So, bearing capacity factor NC for different rod and traffic condition both without and with geotextile separator. This after Stuart's 1977. So, here condition when without geotextile and rod is less than 50 millimeter, but traffic passes of 18 kilonewton axial equivalent greater than 1000, then bearing capacity factor is NC is equal to 2.8. This you have to remember. When the rod is greater than 100 millimeter, but traffic number less than 100, then the bearing capacity factor NC is equal to 3.3. And with geotextile, if the rod less than 50 millimeter and traffic is greater than 1000, then bearing capacity factor NC value is 5. And when the rod greater than 100 millimeter and traffic is less than 100, then bearing capacity factor NC is equal to 6. So, we will determine that NC factor without and with geotextile, and we will check up what is the benefit of the use of the geotextile material in unpaved road. So, this US Forest Service, this is the design curve, and different design curve have been prepared. This for the single wheel load, this for the dual wheel load and this for the tandem wheel load. So, here is the single wheel load and the tar pressure is 550 kilopascal, and for the dual wheel load also the tar pressure is 550 kilopascal, and also the tandem wheel load the tar pressure is 500. So, we can use the chart as per requirement. So, this will give you the what will be the undent shear strength in this axis, and then the what should be the depth in millimeter. That means from this chart we have to calculate the C into NC or CU into NC. So, we know from the side what will be the undent shear strength of the soil, that means CU. And when you know the CU value, so you can also calculate what will be the CBR value. And then from that you know what will be the value of NC, you can calculate what will be the bearing capacity factor, and this multiplication of Cu and the bearing capacity factor, you can obtain Cu into Nc. So whenever you know that Cu into Nc, then for a particular that wheel load, okay, whether 22, 45, 67 or 89, so you can directly determine that what will be the thickness of the pavement, whether it is a single wheel load, dual wheel load and the tandem wheel load. So this way we will calculate what will be the thickness of the pavement. I will give one example later on. So this is the procedure. Step 1, that calculate the strength of the subgrade soil at different location. The subgrade soil strength can be determined from the field CBR, vane shear, cone penetrometer and resilient modulus test. So when you can calculate what should be the CBR value, then you can calculate also unlaid shear strength of the soil C is equal to 30 into CBR, that is in terms of kilopascal. So either you can determine what is the unlaid shear strength of the soil, or if you calculate the CBR, then you can calculate what will be the unlaid shear strength of the soil, that you multiplied by 30 into CBR. Step 2, check the type of the loading. So it may be single wheel load, it may be dual wheel load, or it may be maximum dual tandem wheel load. So as I have shown you that earlier the different chart is there. So accordingly you have to select that what is the type of the loading you have considered in the design. Step 3, you check the amount of traffic, let us say is equal to 6,000 passes. And step 4, check the rutting depth. It may vary from 50 millimeter to 75 millimeter. Step 5, determine the bearing capacity factor NC without and with geotextile material. Now bearing capacity factor NC for different rut and traffic condition both without and with geotextile separator is given by Stewart et al. 1977. Here we are talking about the rut. If without geotextile, if it is less than 50 millimeter, then traffic is greater than thousands, then bearing capacity factor NC is equal to 2.8. If the rut greater than 100 and traffic is less than 100, then bearing capacity factor NC is 3.3. With geotextile, if rut less than 50 millimeter and traffic greater than 1000, then bearing capacity factor NC is 5. Then rut greater than 100 millimeter, less than 100 traffic, then bearing capacity factor is 6. So we can determine from this table that what will be the bearing capacity factor. Step 6, calculate the required thickness of aggregate from the USFB design chart of different loading condition. Step 7, select the design thickness without and with geotextile, knowing the value of C into NC value. Determine the required design thickness of pavement without and with geotextile. Step 8, determine geotextile surveyability, drainage and the filtration requirement. So this one example is given, then it will be more clear to you. It has design an unpaved road with proper geocentric layer for the condition given. Number of the passes is 1000, single axial load is 80 kilonewton. So single wheel load will be the half of axial load, that means 40 kilonewton. So required tire pressure is 550 kilopascal and rut depth 50 millimeter or less. Characteristics of the subgrade soil, that is CBR value is equal to 0.5 or unlaid shear strength value is 15 kilopascal. So solution, according to Stewart 1977, without geotextile, as per the given data, when the number of the passes is 1000 and rod depth less than 50 millimeter, the NC value will be 2.8. You can see here, this is without geotextile and rod depth less than 50 and traffic greater than 1000. So, bearing capacity factor NC is 2.8. So, that is why this NC value here is 2.8. Okay, number of passes 1000, rod depth less than 50, NC 2.8. So, you know C into NC, C is 15 into NC is 2.8. C is 15 is given here, undent shear strength of the soil 15 kilopascal. So, C is given 15 and NC is 2.8. That means this C into NC will be the 42 kilopascal. Now, from the design chart for single wheel load, so you can calculate the H0. That means you can calculate what will be the depth of the aggregate. So, this is the design chart for the single wheel load. Okay, what tar pressure is 550 kilopascal, and you know that what is the C into NC value, that means 42 kilopascal. So, you know what should be the NC value here, 42, this is about 35, this will be about 42 something about here. And then for this you have to calculate what is the single wheel load, because this wheel load is given is your in your problem, it is that given that load value is here, it is 40, single wheel load 40. So, this will be the 40, okay, for this C into NC value, and this is 40. So, you can calculate what will be the thickness of the aggregate. Okay. So, this will be about 700. This is between 600 to 800. This will be about 700. So, that is why depth of the aggregate H0 is equal to 700 millimeter. So, you know C into NC 42, and correspondingly you can calculate for that 40 kilonewton wheel load. So, you can calculate like this, C into NC you know 42, this 42, and then you can calculate thickness of the aggregate. So, H0 is equal to 700 millimeter. Similarly, with geotextile, as per given data, when number of passes 1000 and rod depth less than equal to 50 millimeter, NC is 5. So, you can see from this diagram, with geotextile, rod depth less than 50 millimeter and traffic is 1000. So, bearing capacity factor NC is equal to 5. So, you can write here that NC value is equal to 5. Now, C into NC, C again is 15, NC is 5, so 75 kilopascal. Now, from the same design chart, you can calculate what will be the depth of the aggregate. So, you can see this C into NC is 70. So, this C into NC is, this is about 75 kilopascal. So, this is 75 kilopascal, and this is your wheel load, and then you can go horizontally, which will touch the y-axis somewhere here. So, this will give you in between the 400 to 600 millimeter. That means it will give about maybe 500 millimeter. So, depth of the aggregate with geotextile is 500 millimeter. So, you can observe that without geotextile, your depth of the aggregate is 700 millimeter. So, with geotextile, the depth of the aggregate is 500 millimeter. So, that means you can reduce the thickness of the pavement. So, thickness of the aggregate shape due to application of geotextile, that is delta H, will be equal to 700 millimeter minus 500 millimeter, or 0.7 minus 0.5 is equal to 0.20 meter. So, that means percentage of saving is about 0.2 by 0.7 into 100, the 28.58%. So you are saving about 29% is saving. So quite a good amount of aggregate you are saving when you are using this geosynthetic material as a separation. Here just shows this diagram for the unpaved road without and with geosynthetics. When the without geosynthetics, this thickness of the pavement is 700 millimeter, and when the geosynthetics is introduced in between the subgrade and the base layer, then the thickness of the pavement is about 500 millimeter. And as usual, we use that, you know that this is the sub-base course, this is the base course, and these are the surface course and the wearing course. So according to the IRC code specification, you can select. Now this is modified California bearing ratio test. This we call that reinforcement ratio or LCR. This is the ratio of load carried by the soil with geotextile to the load carried in unreinforced case. Here laboratory modified CBR test for determination of reinforcement ratio without geogrid and with geotextile are shown. This is without geogrid, and this is the soil, and this is at a particular moisture content and the in situ density. And then the top of this soil you are placing this aggregate, and the right hand side you have modified the CBR mold, and you are placing the soil at the bottom layer, and the top is the aggregate layer, but in between the interface between the soil and aggregate, we are placing one layer of the geosynthetic material, which will act also as a separation. So here bottom layer also soil, but top layer is the aggregate layer. This we have made in a modified CBR mode. Now you are to apply the load here, and you measure that, you know that some soil, what should be their sinkage limit, liquid limit, and the plastic limit. You know that what will be the moisture content and the in situ density. So what we do when we perform the test? So let us say this is the mold, and the lower part is the soil, and upper part is the aggregate layer. And in case of the reinforcement, lower part is the soil and upper part is the aggregate layer. And in between here we are placing this geosynthetic material. Now if the soil is at the bottom, aggregate is at the top. So when you apply the load and you measure the what should be the deflection. So for a particular moisture content, you measure what should be the deflection in millimeter, and correspondingly what should be the reinforcement ratio. One, with the defined moisture content, you can take the defined moisture content and you measure the deflection. Let us say deflection is 3.3 millimeter, 4 millimeter, 5 millimeter, 6 millimeter, and correspondingly what should be the load for the unreinforced case. Similarly, what should be the load for the reinforced case. So if you take the ratio of the load carried by the soil with geotextile to the load carried in the unreinforced case, will give you that what will be the reinforcement ratio or the LCR. So you can calculate the LCR value. So for a particular deformation deflection, so you can calculate that what will be the reinforcement ratio value. So you know that what will be the reinforcement ratio value, or it called the LCR, also layer coefficient ratio. So this is important to us, that what should be the LCR value. So this value, ratio value at each deflection, it increases when the moisture content also is increasing. So from this test you can roughly calculate that what will be the thickness of the stone aggregate. So this is given by US Army Corps of Engineer, modified the CBR design method WSTR 3692 as reported by Koiner 2005. So this is the equation. So H is equal to 3.24 log n plus 2.21 into P divided by 36 into CBR minus A divided by 2030 whole to the power half, where H is the thickness of the stone aggregate in millimeter, N is the number of the passes of traffic, and P is the equivalent single wheel load, that is Newton, and A is the contact area of the tire. Now only this CBR value will change when there will be no geotextile material. So you know what will be the CBR value, and when there is a reinforcement, then this CBR value will change. So this CBR value is on the higher side with respect to the unreinforced soil, and that's why the thickness of the stone aggregate will reduce. So in the reinforced condition, you can see that CBR will be equal to LCR into CBR of unreinforced. So we will see some example. So here is one example. So let us say equivalent single wheel load is 40 kilonewton for 1000 passes. Tire contact area A is 300 into 450 millimeter square, and CBR in unreinforced is given 1.5. After placing the geosynthetic material, you can calculate what is LCR. LCR is equal to 1.6. So you can have that what will be the LCR versus the CBR relationship. So if you know the CBR for a particular geosynthetic material, you can calculate the LCR. I will also show you later on what will be that nature of the curve and how you can calculate the LCR for the defined value of CBR. So from that design chart also you can calculate that what should be the LCR value for a particular geogrid material. So evaluate the percentage of saving in aggregate thickness. Now you know this equation for the determination of the aggregate thickness. Now without using geosynthetic material, H0 is equal to 3.24, N value is thousands, that's why log of 1000 plus 2.21, and this is P, and this P is P divided by 36 into this. So you know that this is the P is this is in terms of, this is 40 kilonewton, so this is in Newton. As I say, this equation in terms of the Newton, this divided by 36, and this CBR is 1.5, and this is your A is this 300 into 450, so this is 300 into 450, this divided by 2030 whole to the power half. So you can obtain H0 is equal to 309.78 millimeter. So using geosynthetic material, LCR value is, let us say, 1.6. So CBR in reinforced will be 1.6 into 1.5 is 2.4. Now let us say that with geosynthetics the thickness is H of dash. So H dash is equal to 3.24 log, this is N 1000, this is plus 2.21, this will be the same as it is, this all same as it is, only here this CBR value is changed. So CBR value, reinforced case, it will be 2.4. So this will be 2.4. Okay, instead of 1.5 which was there in the unreinforced case, this is 2.4. So if you now calculate, then you can obtain the H dash value is 237.54. So you see the difference between without geosynthetics thickness of the pavement 309.78 millimeter, with geosynthetics thickness of the pavement 237.54 millimeter. So 7 in stone aggregate delta H is equal to H0 minus H dash is equal to 309.78 minus 237.54 millimeter is equal to 72.24 millimeter. That means percentage of saving is equal to 72.24 divided by 237.54 into 100, about 30.41 percentage of saving. So this is based on the laboratory and the modified that CBR mold, and this test has been performed. This is just for get some idea about the effect of the geosynthesis material for the pavement design. So this will give you some rough idea about this laboratory system. Now this table shows the relationship between CBR value and the thickness of the pavement of wheel load is per kilonewton. Area is the same 300 by 450 millimeter square for different coverage. So here you can see CBR value different percentage 0.51, 1.52, it's all very poor soil, and N value 10, 100, 1000 and the 10,000. For any value of the CBR and for the number of the passes, so you can directly determine what should be the thickness of the pavement. So you can directly determine from this table. So this is 40 kilonewton, I say the wheel load, tire pressure is the same, and let us say if it is a CBR value 1.5 and this value N value is thousands, you can see that thickness of the pavement is 309.78. You can see approximately you can have the same value 309.78, and if this pavement thickness about 2.4 what we have obtained in between 2.4, let us say 2.5, and this N value is about 1000. So you can see that thickness of the pavement will be 231.93. So you can see 237.54. Okay, because here it is little bit 2.4, little bit more. So this will be approximately you can get some idea that what will be the thickness of the pavement with it. You can draw the curve between the thickness of the pavement and for defined value of CBR and under the N value of 10 and 100 and 1000 and the 10,000. So from this chart also, if you know what is wheel load, there is 40 kilonewton, tire contact area A 300 into 450 millimeter square and LCR 1.6. For any value of CBR, you can also directly calculate that what will be the thickness of the pavement. You can see for the 1.5 whatever this is about 300 something. For this 2.4 value, this will give about 237. So also this some design chart has been made. Now, so far we talk about with geosynthetic some material, how to determine the thickness of the pavement, and here the design chart for geogrid reinforced unpaved road. So if you take the geogrid reinforced unpaved road, how you can calculate the thickness of the pavement from this design chart. Now for this design chart, you should know how to use this star, and this design chart has a standard axial load, and that is equal to 80 kilonewton, and number of the vehicle also passes from 10, 1000, 10,000, 1000, 10, 100, 1000 and the 10,000 passes. I will just show you enter from here. So this is the design chart, and this is the standard axial load. I say that 80 kilonewton, and the number of vesicle passes is n is equal to 10 passes, n is equal to 100 passes, this n is equal to 1000 passes, and then n is equal to 10,000 passes. And this right hand side of the chart is for the unreinforced case. That means without geotextile, there is no reinforcement. And there are, you can see that one form and another is the dotted line. The form line indicates the rod depth, that is R, designated as R. If the rod depth is 0.075 meter, then you can use this form line. And if it is the rod depth is 0.15 meter, then you can use the dotted line. And this x-axis show that what will be the undrained shear strength of the soil, Cu in kilopascal, or the California bearing ratio, that is CBR. So from this curve, you can calculate what will be the thickness of the pavement H0 without geosynthetic. That means if you know either the Cu or the CBR value, and if you know what will be the number of the passes, then you can calculate what will be the thickness without geosynthetic material for unpaved road case. So next, in the left hand side, you can see that this is R. R is nothing but H by H0. H is equal to the thickness of the unpaved road with geogrid reinforcement, and H0 is the thickness of the unpaved road without geosynthetic material. So R is the ratio of thickness of the pavement with geogrid reinforcement and the thickness of the pavement without geogrid reinforcement. So this left hand side is for the thickness for geogrid material. So you can, from the left hand side, you can calculate that what should be the R value. So this is kind of the soil, it may be the very soft or the compressible foundation soil for unpaved aggregate. And you know that what is the mechanism of reinforcement, or increase the soil strength, or enhance the load spreading, and membrane supporting by the control the rutting. And this kind of the design chart is recommended for use, and you can find out also the defines what will be the required thickness of the stone base, which you can compare with the cost of the installed geogrid material. So when you will use the curve on the left hand side, so you know what will be the thickness of the unreinforced case, and then you extend it and you select the geogrid material. This is the different geogrid material. So you can select the geogrid material. So then you can calculate what will be the value of R. If this line touches in between, R is equal to 0.5 to R is equal to 0.5, then you can interpolate and can calculate what will be the value of R. So if you know that what will be the value of R, that means R is the ratio of H by H0. So H0 is known to you, R is known to you, so you can calculate what should be the thickness of the pavement with geogrid material. So I am giving one of the example, that for example that N value we are considering 10,000 and rod depth is equal to 75 millimeter and CBR is equal to 1. So you calculate what will be the H0. So when that n value is the 10,000, that means you can use this chart that CBR value is 1. This is the CBR value is 1. So if you know CBR value is 1 and number of passage is 10,000, number of passage is 10,000, then CBR 1 and number of passages, you can go vertically up and number of passages 10,000. Okay, and R is equal to 75 millimeter. So you can calculate that what will be the thickness of the pavement without geotextile. Let us say this value H0 value is somewhat 0.75, in between 0.5 to 1.75. So H0 is equal to, we obtain 0.75 meter, okay, without geocentric material. Now we select the sum of the geogrid material. Let us say we select this geogrid material, okay. So you can proceed further, and let us say we have selected, this is the geogrid material BX1220. So then it will meet at this R is equal to 0.50. That means we know what is R for this geogrid material. So we can write that R is equal to 0.5. So we know that R is equal to H divided by H of 0. Okay. So H will be equal to R into H of 0. What is R? R we have obtained 0.5. So this will be 0.5 into, and H0 is 0.75. So this is 0.75. So this will give you about 0.375 meter. So with geogrid, so thickness of the pavement is 0.375. For example, if I say that if the curve somewhere here, then you can interpolate between 0.45 to 0.5. Okay. So what will be the aggregate shape? So aggregate shape delta of H will be equal to 0.75 H0 minus 0.375. That means this will be the 0.375. That means you can save almost the 50%. So this way you can use this also, the design chart. Next, I will explain design of pavement, unreinforced and reinforced condition. Design of pavement thickness without geogrid as per IRC 37. Step 1, determine the axial load, wheel load P and tar pressure P. Step 2, determine the subgrade CBR value. Step 3, determine traffic loading category. And step 4, as per IRC 37-2001, determine the lane distribution factor D depending upon the type of the road as per IRC 37-2001. So this is the lane distribution factor D for different types of the road as per IRC 37-2001. Now you can see that type of the road, it may be single lane road or intermediate width road, 2-lane single carriageway road, 4-lane single carriage load, dual carriage load, dual 2-lane and greater than 2-lane. What will be the lane distribution factor in terms of the percentage of the total number of commercial vehicle in both the direction, whether it is a single load, it is a 100% intermediate width road, or the 2-lane carriage road is 75%, 4-lane carriage load 40%, and dual 12-lane is 75% and greater than reduced by 20% for each additional load. this is code has been specified to calculate that what should be the value of D. So D you can calculate that what percentage, and that depends upon the what will be the type of the road. For example, that if we consider 2-lane single carriageway ferry load, so then we will say that commercial vehicle for both directions, this is the load distribution factor, that means capital D will be equal to 75%. So we will use this table based on the type of road. Okay. Next, determine the initial traffic, that means A, in the year of completion of the construction in terms of the number of commercial vehicles per day. So this is the equation given by the code. A is equal to P into 1 plus R whole to the power X into D. A is the initial traffic in the year of completion of construction in terms of the number of the commercial vehicle per day. So you will be knowing what will be the commercial vehicle per day, you have to calculate. So P is the number of the commercial vehicle as per the last count. R is equal to annual growth rate of commercial vehicle in percentage. X is equal to number of the year between the last count and the year of completion of the construction, and D is the lane distribution factor in percentage, and this lane distribution factor you can determine from the table. And determine vehicle damage factor depending on the initial traffic volume A. So during the construction period, form this following table as per IRC 37-2001. So you can see that initial traffic volume in terms of the number of commercial vehicles per day, it's called CVD. If it is a 0 to 150 and vehicle damage factor, it is a rolling or plain terrain or hilly terrain. So if it is lies between 0 to 150, so if it is a rolling and plain, this vehicle damage factor you have to take 1.5. If it is a hilly terrain, this vehicle damage factor is 0.5. If this 150 to 1500, then this vehicle damage factor is 3.5 and hill terrain 1.5. Similarly, if it is more than 1500, then this vehicle damage factor 4.5 and this hilly terrain is 2.5. Now determine the cumulative number of standard axial load NS. So you have to calculate what will be the standard axial load with this equation. NS is equal to 365A into 1 plus R to the power N minus 1 divided by R into F, where NS is the cumulative number of standard axial load, that is MSA. And you know that A is equal to initial traffic in the year of completion of the construction in terms of the commercial vehicle per day, and R is the your annual growth rate of commercial vehicle in percentage, and N is the design of the payment after completion or year, and F is equal to vehicle damage factor. So you can calculate the vehicle damage factor from this depending upon the what will be the commercial vehicle per day passing. So you can calculate the damage factor, that means F. Now step 5, knowing the value of CBR and NS, determine the total pavement thickness H from the following design chart. So this design chart determine what will be the pavement thickness. So it gives that relationship between that what should be the thickness of the pavement. You know there is a design traffic, and this traffic lies between 1 to 10 MSA. You can see it starts from the 1 to 10 MSA. So this design chart is only for 1 to 10 MSA, and this is the defined value of CBR, California Bearing Ratio value. So it may be 2%, 5%, 7%, 8%, 10%. So, knowing that what will be the traffic, that means which may lie between 1 to 10 MSA. So, you know what is CBR value, then you can calculate what will be the thickness of the pavement. This all we are talking, this design chart based on the IRC code specification, and this is mainly for the unreinforced soil. So, there is no geotextile or geogrid material. So, this design chart show that how to calculate the thickness of the pavement without geotextile material, where the traffic is 1 to 10 MSA, and also for various value of the CBR. Similarly, this is another design chart for determination of the pavement thickness. This is the design traffic. Now, here design traffic has increased from 10 to 100 and 50 MSA. So, if the 10 to 150 MSA for the defined value of CBR, you can also calculate what will be the thickness of the pavement. So, there are two charts. One is lies between 1 to 10 MSA. This design chart is lies between 10 to 150 MSA. So, knowing that what will be the design traffic in terms of MSA and knowing the value of CBR, you can calculate what will be the thickness of the pavement. So, this way you can calculate that what will be the thickness of the pavement for unreinforced case. So, this we follow this design chart as per IRC. I say this is for the unreinforced soil. There is no design for IRC for the inclusion of the geosynthetic material design chart, but we will show you some of the design chart and how we can calculate the what will be the thickness of the pavement without and with geosynthetic material. So, here is the design chart for the calculation for the thickness of the aggregate. This is single wheel load, one layer system, tower pressure 550 kilopascal, and this is under the various load 22 kilonewton, 45 kilonewton, 67 kilonewton and 89 kilonewton is a single wheel load. In our problem, we have considered only single wheel load is 40 kilonewton. That means we will consider in between these two load 22 kilonewton and the 45 kilonewton. Now, we calculate the C into NC value. You know the unreinforced shear strength and we know the NC. NC for the unreinforced case is 2.8 and C is 15. So, C into NC will be equal to 42 kilopascal. So, then here you can see that C into NC is about 42 kilopascal, and then correspondingly you can move up, and for the 40 wheel load you move horizontally, and this is the depth or this is the thickness of the aggregate without geosynthetic material, which will be about 0.7 meter or 700 millimeter. So, this way we can calculate what will be the thickness of the pavement for unreinforced case. Now, I will discuss for the reinforced case. For the reinforced case, this NC value is 5 and C value is 15. So, C into NC will be 75 kilopascal. So, it will be somewhere here 75 kilopascal. So, E move up and this is 40, that is wheel load, then it move to the horizontally, which will touch this y axis at the depth of 0.5 meter or 500 millimeter. So, this will give about 0.5 meter, this will give about 0.7 meter. So, this way we determine what will be the thickness of the pavement with geosynthetics. So, thickness of the pavement with geosynthetics is 0.5 meter. So, what will be the thickness of aggregate shape due to the application of geotextile? That is delta H will be equal to 0.7 minus 0.5, that means 0.20 meter. So, percentage of saving would be equal to 0.20 by 0.70 into 100, that means about 28.58%. Thank you very much. If you have any question.